Chapter 3 Study Guide, Limits, problem number 4. We're asked a whole bunch of different limit questions about this. So what I'm going to do is I'm going to sketch it for myself, because then it'll look much nicer and I'll be able to answer the limit questions easily. So before I can do that, we need to factor this sucker. So let's look at that numerator, 2x squared minus 4x. You should be thinking greatest common factor as always. So I'm going to pull out a 2x, and I'm left with x, because 2x times x is 2x squared, minus 2, because negative 2 times 2x is negative 4x. Cool. Then my denominator, I'm going to factor out the greatest common factor of x, so I get x times x squared minus 9. Well, x squared minus 9 I can write as x minus cubed, x minus 3x plus 3, because it's a difference of cubes. So now I can see that I have a factor of x in the numerator and the denominator. So I'm going to get a big ol' hole right there at x equals 0. And I can see I'm going to get a vertical asymptote at x equals 3 and negative 3. And I can see that my function is going to equal 0 at x equals 2. Okay, so now I'm going to draw myself some axes and start sketching this out to see what it looks like. So let's go ahead and mark what I know. So I know I have a 0 at 2. So I have a 0 right there. So you have a vertical asymptote at negative 3 and positive 3. So I'm going to sketch that in. This is killing me. That y-axis was way too crooked. I had to fix that. Hopefully it's a little bit better now. But let's see, where was I? So I got my vertical asymptotes, I got my 0. I know I have a hole at x equals 0. I need to figure out where it is. So we'll have to look at the limit in a moment. But before we do that, do I know anything else? Well, let's see. I have a degree of 2 in the numerator and a degree of 3 in the denominator, so my horizontal asymptote is going to be 0. So I'll add that later, but let's now figure out where this function is going at x equals 0. So to do that, I look at the limit of my function with the hole removed as x goes to 0. So now I can just directly substitute to get 2 times negative 2 over 2 minus 3 times 2 plus 3. So again, simplify that. I get negative 4 over 2 minus 3 is negative 1 times 2 plus 3 is 5. So I get, what am I doing? Alright, Mr. Reed's tired, and he put in 2, he substituted in 2 for x instead of 0, so I need to make that change. So then I get negative 4 over 0 minus 3 is negative 3, times 0 plus 3 is 3, which is negative 4 over negative 9, which is positive 4 over 9. So now the whole point of that was to figure out where my 0 was. So 4/9 is like right in there. So I've got a hole right there. So now I can go ahead and actually start sketching this guy and see what it looks like. And my technique I showed you before, I just look at what's happening on either side of my asymptotes. So I usually start left to right. So if I go, let's just use 1 past my leftmost vertical asymptote. So let's check the x value of negative 4. So when x goes to negative 4, I'm just now checking my function to see if I'm positive or negative. So I look at 2 times negative 4, well, that's going to be negative. Negative 4 minus 2, well, that's going to be negative. That's my numerator. My denominator, negative 4 is negative. Negative 4 squared is 16 minus 9, that's going to be positive. So I've got a negative over negative and a negative over a positive, so this thing is going to be negative over here. So I'm looking like that. Now I'm going to do the same thing, checking out the other side of that same asymptote. So now let's look at an x value of 2. So when x equals 2, again, or I'm sorry, negative 2, boop, because I'm looking right here, where's my function, above or below? Now I already know it should be above, but we'll just go through it anyways. When I'm at negative 2, 2 times negative 2, well, that's going to be a negative number. Negative 2 minus 2, that's going to be a negative number. Negative 2, that's a negative number. Negative 2 squared is 4 minus 9. That's going to be a negative number. So now I got a negative over negative, negative over negative, so I'm going to be positive. Boop, 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 boop. And I know I'm coming down to hit that hole right there. Already found that guy. And now I got to cross the x-axis there to make my 0. So I know I'm going to be coming down like that and hitting that, but I don't know if I'm going back up or going down. So let's just check some value in between that 0 and our vertical asymptote at x equals 3. So let's try, say, 2.5. So if I try 2.5, I get 2.5 times 2 is a positive number. 2.5 minus 2 is a positive number. 2.5 is a positive number. 2.5 squared minus 9 is a negative number. So I get positive over positive, positive over negative. My function's got to be negative, so I'm coming down like that. Last step, finally, check something bigger than 3. So let's go 4. 4 gives me 2 times 4 is positive, and 4 minus 2 is positive. 4 is positive. 4 squared is 16 minus 9 is positive. So I have to be positive here. So I got to be going like that. Cool. All that work, and I haven't even answered the question yet. But I have an awesome graph, so it's going to make answering these questions super easy. So the first one, as x goes to 0 from the right, as x goes to 0, well, it's the same as it goes from the left, so it doesn't really matter. We already figured out what that was. That was where our hole was, which is 4/9. Part B says as x goes to 0, again, it agrees from the left, so our limit is 4/9. We already proved that algebraically. Now if you look at the limit as x goes to 3 from the positive side, we're looking over here as a positive side, we're going up, up, up to infinity. As x goes to 3 from the negative side, we're going down, down, down to negative infinity. And now as x goes to negative 3 from the positive side, so now we're looking over here, we're going up to infinity. And then as x goes to negative 3 from the negative side, we're over here, again, we're going down to negative infinity. That's what that symbol is. And finally, what's happening as x goes to 2? Well, as x goes to 2, we already found out that's our 0. And yeah, they agree. Our function goes to 0. We're done now. Yay!